What's up guys, James here, how are you doing? So I'm going to be avoiding drama today. I'm going to be talking about something which actually really interests me for a change, and that's alien life, exoplanets and the future of space travel. So I've been absolutely fascinated by the subject since I was about 5 or 6, when my dad bought me a few books about cosmology and the solar system. I remember in about 1992, 93-ish, I was about 5 or 6 at the time, I was being taught about it in school as well, and after the teacher explained about the 9 planets in the solar system, now it's 8, so I might get to why Pluto is declassified later in this video. But yeah, she explained about the planets in the solar system, and she explained that our sun was simply a star, just like all of the other ones that we can see. And she explained that there's 100 billion galaxies and 100 billion stars in each one. So, after she'd explained all this and she asked us if we had any questions, I asked her if there was any possibility for planets outside the solar system. And she just said flat out no, there's no planets outside of the solar system. Now, even at that young age, I realised that this was simply nonsense, and it was at that moment that I realised that, yeah, adults can be just as dumb as kids. I knew that planets were extremely small in proportion to their stars. I also knew that they didn't give off any light, so they'd be very, very difficult for us to actually spot. And also there was simply no way that we'd studied all of the 10 hexillion stars in the universe. It's the same attitude which people have had for millennia. Since humans were around, probably, we've had this attitude that the Earth and our solar system is in some way just special and unique. We thought that the Earth was flat at one point, then we believed that the Earth was the centre of the universe, then we believed that the Sun was the centre of the universe. It seems that the more we learn about cosmology, the more we learn that we really aren't actually that special. The Sun's a pretty average star, and there's billions of them. So it wasn't until 2005 when I actually got to have a little laugh to myself about how she was really wrong on the subject when we discovered the first exoplanet. And it wasn't until 2003 when we actually started discovering them quite regularly, and since then it's been increasing exponentially. So, especially over the last year, we've been discovering hundreds of them. It's really quite incredible how many we've discovered. Our instruments are getting better all the time, and we can discover smaller and smaller planets with far greater accuracy. And I actually discovered my own exoplanet quite recently, and the lovely Zongits Chris did a painting for me. I know you can't see it very well there, so I'll flash up a couple of images on the screen now. So, a lot of that is pure artistic license. All that we actually know is that the Sun and the star in that system is about 0.6 solar radiuses. We know that it's a few hundred degrees cooler than our Sun, and we know of 2 planets there. The first one, the main one in the painting, which is there, is I'm calling Karina, because Zongits did the painting for me, and we know it's roughly Neptune-sized. It has an orbit of about 90 days, and that would roughly put it in the habitable zone of the star. Unfortunately, because of its size, it's most likely a gas giant, so it's very, very unlikely that there could be any life on it. But Zongits did draw some moons around the star. The painting's done from the perspective of just behind a moon which looks similar to Mars in terms of its texture and its landscape, and there could well be moons like that around it which could support life. The other planet I discovered is roughly Earth-sized and has an orbit of about 5 days, But of course, because it's so close to the star, it wouldn't support life, and it would in fact be considerably hotter than Venus. So at the moment we've got two main ways of discovering exoplanets at the moment. We can either look at the red and blue shift of a particular star. If you get blue shift, that means that the light we get from it is going towards the blue end of the spectrum. That basically means that the star is moving towards us, and if it's shifting to the red, that means that the star is moving away from us. This basically works like the light equivalent of the Doppler effect. And using this method, you can see how long the length of the year of a particular planet is, and you can also work out the mass of the planet. The other way is the transit method, and basically what that includes is looking at the light coming from a star. So we've got a star here, and if you've got a planet coming around it, when it goes in front of the star, you're going to see a dip in the amount of light you receive from it, and by looking at the dip in the light levels, you can determine whether or not there's a planet there. So this is a very much exaggerated example of what you might see from a light graph of a star with a big planet in front of it. This is very much exaggerated. The noise level is very, very low, and the planet is very, very big, which makes it easy to spot. Normally it's nowhere near this simple, especially when we're looking for small planets. So you can see on the left, when the planet isn't in transit, the amount of light you'll see will be roughly level. As the planet moves in front of the star, when it starts its transit, the light level will drop a little bit, and then there will be another plateau as the planet's in full transit, until eventually it comes out and the dip gradually starts to decrease again. You can also use the transit method to spot binary star systems. You end up seeing a very, very distinctive double dip pattern when it's a binary star. This is because one star will likely obscure the light considerably more than another. How you can tell that this isn't simply two different planets is that for a start, the dips will be considerably larger than anything you'd see from planets, even from hot Jupiters. And secondly, the dips are the same distance apart, and we simply don't see two planets which have the same length year in the same star system. Finally then, here's an example of real light data from the star where I discovered my two planets. Outlined, I've got where I suspect the Neptune-sized planet is, and I couldn't say that that was real and not simply a glitch until I'd spotted the same level of dip on 3 separate occasions, and the same for the Earth-sized planet, which is considerably more difficult to spot. So the Kepler projects are behind this. All of this data is now available to the public, and the public can assist in finding new planets themselves. You can help discover new planets at planethunter.org, and of course I'll leave a link to that down in the description. It's worth repeating that finding Earth-sized planets within their habitable zone is still an extremely difficult task. Not because these planets are particularly rare, but simply that we need extremely sensitive equipment in order to do so. And, there's good reason why it took us so long to even find what we'd classify as hot Jupiters. That's giant Jupiter-sized planets orbiting extremely close to their parent star. So, finding an Earth-sized planet around a star is basically equivalent to spotting a fly going in front of a car's headlight from thousands of miles away. The equipment we need has to be so precise that there is very good reason why we haven't been able to do so until extremely recently. So most of the planets we discover are what we classify as hot Jupiters. Very, very big planets aren't too difficult to spot, and also if they're very close to the parent star, then we don't have to wait too long before we actually spot a transit. So people actually think I'm pretty crazy for saying this, but I think we'll have pretty solid evidence of alien life within the next 3 to 5 years. Now, the reason I'm saying such a small amount of time is because we've been discovering hundreds of planets over the last few years, and we'll be able to use spectrography in order to detect the atmospheric composition of the atmospheres of exoplanets. We might detect high levels of certain organic molecules. We could also detect fairly rich amounts of oxygen in an atmosphere, and that would be pretty good evidence that there was life causing it. Now, the reason for this is that life seems to be the only way in which to get a lot of oxygen in an atmosphere like we have on Earth. Because H2 is the most common molecule in the universe. Water is the second most common, because when you've got oxygen, chances are there's also going to be a lot of hydrogen as well, and that will end up forming loads of water, and the oxygen simply won't be free in the atmosphere. It seems that the only way we know at the moment is for a biological process such as bacteria converting carbon dioxide into oxygen. In terms of what life would be like outside of Earth, I think we may actually be quite surprised by how similar it is to what we see here. Now, a lot of it is pure speculation, but I do think that there's certain assumptions which are quite reasonable. Now, for a start, the laws of chemistry and physics are the same throughout the universe from our observations. So, we can look at the orbit of planets, we can look at the stars themselves, we can look at the chemical composition of them, we can look at how much energy they give off, and from that alone we can determine the speed of light's consistent, we can determine that the strong and weak nuclear forces are the same because of the fusion process from the star, we can determine that electromagnetism acts the same, and we can determine that the same elements are there, which we would know anyway because of our knowledge of the periodic table. When it comes to life, there's certain chemicals which we can rule out of the process, and other chemicals seem extremely likely. Carbon, for example, seems like the most logical thing. Like the most logical organic element, simply because it's extremely versatile. It can form in flat sheets, tubes, balls. It can form little hexagons. It's flexible enough that it can be. It's flexible enough so that it can form a very wide variety of complex shapes and work in many different situations, and it's also reactive, but not so reactive that it becomes unstable. The planet is most likely to have lots of a liquid, because chemical reactions happen a lot better in liquids than they do in solids or gases. The planet would have to be close to that liquid's triple point as well. So Earth is close to the triple point of water, so we've got liquid, solid, and vapor water on Earth. It's possible that it could use something like methane, like we see on Titan. Titan also, it doesn't have a water cycle, it has a methane cycle. There's rivers of methane, oceans, there's clouds, there's rain. So that's another possibility as well. It seems likely that life will be based on nucleotides and amino acids, because their chemical, the way they're constructed, it seems to have unique properties which seem to be necessary for complex life. So they can form in chains. They can be broke down. They can work as what you would call a code. And they can curl into complex 3D structures. So it does seem extremely likely that that's the case. We've discovered amino acids and nucleotides are outside of Earth as well, on comets and asteroids and that kind of thing, many of which are completely different to the set of 20 amino acids which all life on Earth has. So we may well see life which uses a completely different set of amino acids. As far as abiogenesis is concerned, how the first life gets there, I'll leave a link to a video below, which is quite interesting. It can show how it can happen from something really simple. Now, when it comes to complex life, I think that in some ways it is likely to be very similar to that on Earth. So, if the Earth has a power source for life, and that's the sun. Life will find a niche if it's that useful. So that's why we have photosynthesis. It's likely that life on another planet will also utilise the light and heat from its star as an energy source as well. So if you see photosynthesis, the only logical way that you're going to see complex organisms utilise it is by getting a large surface area. So you're going to get something similar to leaves, which faces towards the sun. Also, they're going to try and compete with each other, so they'll grow tall and thick if there's a lot of gravity in order to outcompete the other organisms. It's also likely they're going to be rooted to the spot because light doesn't give you that. It gives you a lot. It gives you enough energy to live, but not enough to really move about very much. So it's likely that the equivalent of plants is going to be rooted to the spot, large surface area like leaves, and quite tall. So you'll have things similar to trees. There will also be things which will eat the plants because, like I said, life finds a niche. If there's an opportunity it can exploit, it's going to evolve in order to do so. You're then going to see things which eat the plant eaters, and you're going to see things which eat both. You're going to see things which break the top of the food chain down so that the things at the bottom of the food chain can utilise it. So, if that wasn't the case, the life there would go extinct very, very quickly. So in those ways, I think it is likely you're going to see things very, very simple. If there's complex life as well, you're going to see things utilise as much of a planet as possible. You're going to see things in the water, the land, and the air. You've got fish, land animals, and birds, or insects, effectively. You're going to see things which are very, very similar. Also, you've got there's things like convergent evolution. Now, lots and lots of animals which don't share a common ancestor on Earth have evolved similar solutions to deal with similar problems, such as insects and birds and reptiles and mammals have all found ways of flying. Even some fish have found ways of flying. They've separately evolved wings. It's the only solution to deal with that particular problem, so it's likely that will be the case on another planet. If you've got photosynthesis, it's likely that on complex life, it's likely you're going to have animals which utilise that in order to be able to see and avoid predators and hunt. So you'll see eyes evolve. Now, on Earth, you've got octopuses and vertebrates. Both have the same camera eye style. They evolved that completely separately, yet the design is very, very complex and is nearly exactly the same in many ways. So, that shows that they found the same solution to the same problem completely independently from one another. And it's likely that would be the case when you've got complex life on another planet. Also, there's good reasons why hearing would evolve, being able to detect vibrations, being able to avoid things which are poisonous. You're going to have taste and smell. It's guaranteed that you're going to have touch. Something, if it detects a predator on them, it's going to move. If it doesn't, something would evolve in order to do that, and the ones which do would completely dominate the gene pool. So there are certain things which I think are reasonable to assume. So, sorry about the change of scenery, my flatmate's gone to bed now, so I'm having to film the rest of this downstairs. Now, when it comes to sentient life, I also think that there may be many ways that it would be very similar to us. For a start, it's quite likely, I think, that they may be bipedal. Certainly, with humans, our brains didn't really start expanding that much until a little while after we became bipedal, and then our brains expanded to 3 times the size in the space of about 4 million years. Now, And nature and evolution simply doesn't like waste. If our brains use a lot of energy, processing uses a shitload of energy, and having extra power there which we don't need is going to work very much against us. Without having the dexterity that we do by standing upright and having our hands free, and being able to make tools and that kind of thing, having all of that extra brain power would have simply just gone to waste and would have been selected against. There's good reasons why our brain expanded so much after we became bipedal. There's good reasons why elephants, despite the fact that their brains are 3 times the size of ours, can't really do very much because they're not bipedal. Their their equivalent to arms is specialised for walking, not for doing doing dexterous things. When it comes to technology, on very early stage, it seems very likely that they would have harnessed fire to keep warm. They'd have built shelters. They'd have built weapons. They'd have done the same kind of things to aid survival that we did. They'd have had to protect themselves. They'd have to build shelters, that kind of thing. When it comes to higher level technology, I think eventually they would have discovered certain objective truths about the universe. It's very likely that they'd understand chemistry, they'd understand maths, and they may well have a periodic table which looks exactly the same as ours because they've got the same elements to deal with. They'll understand the difference between metals and non-metals and that kind of thing. When it comes to long distance communication, there's only really a few ways you can do it. You can do it either with wires or by sending an electromagnetic signal. Works most efficiently in the radio end of the spectrum. And they could also use neutrinos to send long distance signals. That would be quite an interesting possibility as well. They'd most likely discovered and most likely invented the wheel. They'd have transport. If they have a very large population, which you really need if you want to make advanced technology, they'd have had to have fed that population. They'd have tall buildings to house people with multiple layers. There's many ways which they would end up extremely similar to us. Of course, there's a hell of a lot of different ways that they'd be vastly different. But all I'm saying is that I think we'd end up actually being surprised by just how similar they might end up being. So finally, I'm going to talk about the possibility of first contact and the future of space travel. So first off, I have to make this clear: I do not believe that alien life has ever visited Earth, for the simple reason that there seems to be virtually no evidence of this. And I do not believe that faster than light travel is possible, for the same reason I don't believe in time travel or Super Saiyans. And that's simply that it breaks the laws of physics as far as we know, and there's absolutely no evidence that that's ever happened, when there should be absolutely loads of evidence. So when it comes to the time travel example, I saw a movie where someone went back in time and shot a load of bandits with machine guns in the Wild West era. Now, if that kind of thing happened, we would have evidence for it, and people time travelling would fuck things up. They would end up dropping future technology, or seeing someone seeing them who shouldn't have seen them, that kind of thing. We'd simply have evidence that that was the case. If faster than light travel was possible, and travelling through space really was a very easy thing, then aliens would have visited us by now. We'd be aware of their presence. They'd have inhabited lots of planets and terraformed them, and we'd be able to see the evidence for this. But now that simply doesn't seem to be the case. So unfortunately it does seem that we are limited to slower than light travel. Most likely I think we're going to end up using fusion or antimatter when it comes to actually travelling to exoplanets, because the fuel we've got at the moment is thousands of times less efficient and just really wouldn't be up to the job. When I think about what it would be like to land on the moon, I imagine that they'd feel quite similar to how I feel when I climbed a mountain. On the one hand, I feel that it's an amazing accomplishment, and it feels really amazing to have actually achieved something that difficult. But at the same time, I feel like I've achieved absolutely nothing. I'm feeling that it's both an amazing accomplishment and no accomplishment at all at the same time. I've spent energy to get there, I've spent a lot of time to get there, and even money, and not really any real payoff, apart from managing the challenge itself. So I imagine that's what it's like to get to the moon. Yeah, we have learnt things from our trips there, but I don't think that going there would really would justify its cost on an economic level. When I think we might get to Mars in the next 10 years, that would be quite an amazing accomplishment, and we would do it just for the accomplishment itself. But unless there was really any economic gain, unless we mined it, unless we terraformed and inhabited it, it really wouldn't justify the cost to keep going there. So yeah, I think it's really sad that not one living person will have been to the moon in 20 years if we keep on going the way we are. But there doesn't seem to be much reason to keep doing it. We need to basically expand our horizons and go further. The first exoplanet I think we'll go to would be one of the planets in the Gliese 581 system. Really interesting solar system. There's 7 confirmed planets that I know about. 2 of them are very, very close, if not in the habitable zone, so it would make a very good candidate. And it's only 20.5 light years away. Realistically, I do think that getting there is achievable in the next 200 years. We'll have had fusion power for a long time then, and with fusion power we could expect to get to about 20 to 30% light speed. Not only that, but we'd be able to fuel the ship using just a few tons of water. We'd be able to have some of that as drinking water, and then you'd use electrolysis to split that into oxygen, which we'd use for the crew and the ship, and hydrogen as the fuel source for the fusion. Then there'd be no harmful emissions, no radiation, very, very clean method of transport, and I think that certainly is achievable. Once we've been to there, unless we can actually, really colonise it or mine things from there, again, the accomplishment is enough. We're not going to keep going there just for the sake of keeping on going there. And the next challenge on from there would be to make first contact. When it comes to first contact, I think that it's more likely that aliens will make first contact with us than the other way round, for reasons which I'll get into in just a sec. But the reasons for making first contact would be either to examine them, or to contact them, to communicate with them. I think that the chance of aliens or us going to another planet just to start war, just to screw them over, is extremely unlikely. We wouldn't just attack them because they would fight back. If we just wanted land, we just wanted minerals, etc., we would choose an easier target than a planet with sentient life. And I don't think that aliens could possibly be that much of thoughtless killers either, unless they decided that we would be a threat to them eventually. So yeah, we we just wanted land and minerals, we'd go to a different planet. If we were going to a planet with sentient life, it would be to make first contact, more than likely. So, why I think that it's likely that aliens would make first contact with us first. Well, if aliens are sent, if you look at aliens on another planet, with the age of the universe being 13.75 billion years old, the chance of them being on a very, very similar level of technology to us is extremely slim. They'd either be thousands or millions of years behind us, or thousands of or millions of years ahead of us, more than likely. And if they're on a sentient level, we are very much on our infancy, so it's more than likely that they are going to be a long way in advance of us if they're actually sentient. So, how would they make first contact? Well, one way I think we could end up looking for life is looking for for a planet which gives off loads of light. Our planet, because we have the technology that we do, because since the Industrial Revolution, since we've had street lights and that kind of thing, since then our planet has been giving off more and more and more light, and if aliens spotted they would realise that our planet is a very, very good candidate for making contact with. Now, for an alien to have reached us by, say, the year 2000, they would have had to be at an absolute maximum of 50 light years away if they could travel at the speed of light. That's because in 1950 they'd see the Earth as it was in 1900. If they were any further away than that, they'd have seen the Earth as it was earlier, when it wasn't really giving off very much light because we didn't have technology, and so they wouldn't really pay much attention to us. So yeah, if they saw the Earth as it was in 1900 at 1950, theoretically they could get to us by the year 2000. Now, I think it's just extremely unlikely that there's any intelligent life within 50 light years away. Within a couple of hundred, maybe within 1,000 light years, I think it's pretty probable. So I'd say we're looking at about 2,000 years before we make first contact with any aliens. So anyway, that's my thoughts on it. Thanks for watching. Comment, rate, subscribe, and I'll see you soon. Bye.